Okay, let's take a look at an example of another hypothesis testing. Of children and adolescents 6 to 11 years of age, 18.8% are found to be overweight. A school district randomly sampled 130 students in this age group and found that 20 were considered overweight. At alpha equals 0.05, is this less than the national proportion? Okay, so this is now an example of a hypothesis testing where we're not looking at means. Instead, we are looking at studying proportions. So we're testing a claim about a population parameter based off of a sample statistic, in this case for proportions. So as usual, we start out with our hypotheses. So we have our null hypothesis in this case. Now remember, these hypotheses are always statements about the population parameters. So our population parameter for proportions is P. P with the dash is going to be our sample. So P is the one for the population. So if we expect nothing to be different in this school district, we expect it to be the same as the whole population, our P in this case is going to be 0.188. Now remember, we never do computations with percents. Percents are nice to understand things with, but we need to change these into decimals. So our null hypothesis is P is equal to 0.188. Our alternative hypothesis is now, we're asking the question, is this less than the national proportion? So we're wondering, is P going to be less than 0.188? Remember, you could say the null hypothesis is greater than or equal to, but we can just always use equals. Okay, so now that we have that, now we're going to list off the things that we'll need to figure out to determine what test we're going to use. So the first thing that we need to indicate is that this is about proportions. This is not about means. So because this is about proportions, this will automatically cut out different things like the z and the t-test. So we have proportions, and then the other thing that will indicate is that this is for one sample. So this is going to be a one sample test, and then the last thing we could also indicate if we want is that this is going to be a one-tailed test. So this is a one-tailed test. Now, technically, you could also indicate this as a left-tailed test, just because it's a left tail, because that one tail is going to be in the left direction, because we're going to be less than the value. But these two are the important ones that tell us that the test we're going to be using is what's going to be called the one proportion z-test. Now, if you remember when we did confidence intervals with proportions, we had z sub alpha divided by 2 appear in those. So with proportions, those form a normal distribution, so the letter z is going to appear in these. So now if we go over to our calculator, we can turn that on, and then if we go over to our stat option, so press the stat button, go over to tests, you see we have our z-test is the first one, our t-test is the second one. We've used both of those so far, but we're going to go down to the fifth option of one prop z-test. So our one proportion z-test, we're going to press enter. Our P sub 0, that is going to be our null hypothesis. So that's going to be our statement about our null hypothesis, which is 0.188. X, what X is, so if you remember when we calculated these data values back in confidence intervals, X, this was going to be the number of individuals with a certain characteristic. So whatever we're studying, our X is going to tell us the number of individuals with that characteristic. And then N is going to be, like usual, is the total sample size. So in this case, we took a total sample of 130 students, and 20 of them were considered overweight. And so we're studying what percent of students are found to be overweight, so it would make sense to have X be 20, and then N is going to be 130. If we were looking at instead statements about not being overweight, then we could use x would be 110, and we'd have to change what our p sub 0 would be. Now if we go down to choosing the alternative hypothesis, we see that this statement here, this number really corresponds to p sub 0 for our calculator's understanding. So indeed, our proportion is going to be less than p sub 0. So we're going to select that middle one. And then we go down to calculate this. Once we have calculated this, we're going to be able to summarize some of the important things. So our test statistic in this case is going to be z is equal to -1, and our p-value is going to be 0.1595. Now, just as a little note here, you're going to see this p-hat. This p-hat appears. This is going to be the same thing as p-dash. So some statisticians use the p-hat to be the same thing as p-dash. So the third number there, the 0.15384, that number, that's going to correspond to if you calculated 20 divided by 30. So if you do 20 divided by 130, you're going to get 0.1538, blah, blah, blah. So after we found our test statistic and our p-value, now we compare our p-value to alpha. So we can see that since our p-value, which is 0.1595, is larger than 0.05, which was our alpha, we do not reject the null hypothesis. So one thing that we should note is that if this number here we found as our p-dash, we're basically saying that this school, about 15.4% of this school has overweight students. So indeed, this is less than it, but it's not going to be significantly less. So we did not reject the null hypothesis. There is not sufficient. So there's not sufficient evidence to believe the proportion of overweight students at the school is less than the national proportion. And that would conclude our hypothesis testing for this case of proportions.